Hello, it's another A-level maths video here. This one's a statistics video based on the year 1 content. We're looking at section 1.2 of the textbook here. And in this video we're going to look at 3 different sampling methods that we need to know about. Those methods are simple random sampling, systematic sampling and stratified sampling. Now, before we get into those, the specifics of those methods, I'd like you to think about what the difference is between a sample and a census, which we looked at in the last video. And in particular, what does this word biased mean in the sentence here? Pause the video, have a think about it, then restart when you're ready. Okay then, so this is something we looked at in the previous video, and I've written my answer down here. So I would say a sample is biased if it does not represent the whole population. And what we're going to be doing in this video is we're going to be looking at these 3 sampling methods, each of which some way is trying to address this fact that we don't want our sample to be biased. So let's start off by looking at the first of our methods here. This is called simple random sampling, or to choosing a simple random sample. The instructions are given there on the screen, but basically I'll go through it very quickly here, and then we'll have a look at an example with a spreadsheet shortly as well. So the first thing you need to do is allocate a unique number to each sampling unit in the sampling frame. That's each item of data in our population of data. Then we need to find some way of generating a list of random numbers. And then our sample is going to be obtained by matching the random numbers to the appropriate sampling unit in the sampling frame. There is an alternate way of doing things, maybe a slightly lower tech way of doing things, which is basically sort of the names in a hat approach. I've kind of detailed that on the screen as well. That's known as lottery sampling if we do it that way. Now, to demonstrate this, what I've got here is I've actually got a list of the countries of the world here. I'm going to use this to demonstrate here. So we've got, you can see I'm scrolling down, we've got, how many are there? 237 items of data. And what I've done is I have given each one a number. So that's our first thing to do here. So this is how this is going to work here. And I'm going to get my spreadsheet here to find a random sample of 20 of these countries from the list. So here's the first thing I'm going to do. I'm going to get all of the numbers selected here. Now my spreadsheet's got a wonderful sampling feature on it. So with my spreadsheet, I can go there with those numbers selected. I can go up to sampling here, and I can get it to get a random sample of we said 20, didn't we? So I'm going to go up there, sample of size 20. Oh, too far there, back one. There we go. Hit OK. And can you see what's happened here? It's given me a random sample of 20 numbers from that list, which has then picked my sample from the whole list. If I scroll down and you look down the left-hand side, you can see the ones it's picked here. So it's kind of spread them out a little bit, but there's a few kind of bunched together there. But this is what a random sample is going to look like. Okay, hopefully that makes sense to you. What I'd like you to do is think about the question here. Say we had a school and we had some pupils in the school. We wanted to take a simple random sample of 15 of those pupils. How would you do that? What are the steps you would have to go through? Please do pause the video, write the answer down and restart once you're done. Right, let's see what we should have written down here then. So I've got my answer here, I'll reveal it. So the first step of the process would be to allocate a unique number to each pupil. Now there are 120 pupils. It doesn't matter that some are girls and some are boys. We're not that interested for this question in whether they're girls or boys. So we just allocate them all a number from 1 to 120. Then we would use a computer or random number generator to select 15 of these numbers, 15 different numbers, and then the final stage would be to select our sample by choosing the pupils which corresponds to those 15 numbers we've chosen. Did you write down all of those details? Because that's what examiners will want to see, so you can demonstrate that you're doing the right thing here. Okay, so that's simple random sampling. Let's move on to the next sampling method which we're going to look at in this video, which is systematic sampling. The idea of systematic sampling is that it selects every kth member from the population. So basically we just choose one random number, one random starting point, and then we just sort of pick items from the list, every k items after that. So let me show you, before we get into the detail of how we actually sort of generate this, let me show you what we mean by this. I've pulled up the spreadsheet again, and I actually, before we started this video, I actually already found a systematic sample. So what I did is, you'll notice that I've sort of, if you look at the countries which are actually in our sample here, they're very evenly spaced from our set of data. I've actually taken every 12th country here. So the idea is that we kind of work out the interval we want to get the right sample size, and then we only have to generate one random number, which when I did it I generated the number 3, and then we just pick every, in this particular case, 12th country after that 3 there, and we generate our sample that way. So how did I decide to go every 12th item in my list here? How did I decide to make that regular interval equal 12? Well, what I did is I just did a very quick calculation. I knew I had 237 countries in my list. I know I wanted a sample size of 20, so I just need to divide 237 by 20, and that's going to give me my interval that I want. Now in this particular case I didn't get a nice number, it happens to be about 11.85 I think, but that's approximately equal to 12, so that's the reason why I chose every 12th item. So how did I decide to get to that first item in my list? Because I do need to generate the random number here. Well, my calculator's got a wonderful random number feature on it, which I wonder if you knew about already. It's down here. It's can you see where I'm indicating there? It's this function here, the ran int number there. And if I use that and I put in the lowest number I want, which in this particular case was 1, and let's say I want to pick a number between 1 and 12 as my starting number, then I just hit that there, and it's given me an answer there of 11. You want to see if I do it again, I get a different answer there of 6. Let me do it one more time. I get 11 again. There we go, and there I've got a 7. So let me just change this on the spreadsheet here, so you can see what happens if I instead start with the random number I've just ended up with there, which is 7. So I'm just going to take the number 7 and copy it across and put it into here. You can see that it's coming up with another sample here, and you can see here that you know, I've started at 7 this time, and I've taken every 12th item of data after that. So there's my sample which I've got by doing a systematic sample. Make sense to you? Okay, have a think about this question here. How would you take a systematic sample for this situation here, please? Right, how did you get on with this one? Did you have enough detail here? Let's have a look and see. This is what I wrote down. So my first thing that I did was I said I was going to allocate a unique number to each name, and we've got 50,000 names, so from 1 to 50,000. I then did a calculation. I worked out that 50,000 divided by 100, which is our sample size of course, is 500. So that means that I'm going to have to choose every 500th name from the list. I need to find a random number to select my first item in the list. So that means find a number between 1 and 500. So that's going to be the first number in our sample. And then finally, the last thing I wrote here is that I need to choose the name corresponding to that first number, and then every 500th name after that for the sample. Okay, so that's stratified sampling. We've got one more sampling method which we need to look at in this video, but before we sort of get into that in detail, let me just kind of go back to that simple random sample that we did earlier on in this video. Now, I don't know if you noticed something, but we did this completely randomly, and not all of the continents are actually represented in our sample. So if you look down the list here and look down that continents column, you'll see that there are sort of various different continents, but down at the bottom we've got a few countries from Oceania, and it just so happened that the random sample that we ended up with here didn't give us any countries from Oceania. So you could argue, well, maybe that random sample has given us a biased sample there because it's not fully representative of the population. So to try and avoid that, what we could do instead is we could do something called stratified sampling. Now, stratified sampling is really appropriate when we've got a population which divides into groups. Technical name for that is strata. And in this particular case, with our countries of the world, they do kind of divide into those different continents. So if we wanted to make sure that each continent in our particular sample is, or a particular population is adequately represented in the sample, then we may do something like use stratified sampling here. So the idea is really that we try and make sure that each group is represented in the sample in the same or approximately the same proportions as they are in the population. So let's have a look and see how we might do this. Now, on the screen here, you can see I've already kind of counted up how many countries there are from each continent in the population. Now, say I wanted approximately 20 for my sample, then really what I've got to do is I've got to take these numbers in the frequencies, and I've got to multiply by, well, sample size of 20 divided by the population size, because I want about 20 over 237 of each group to be in the sample, because that's how much I've got for the sample. So I won't do the calculations here, I'll just write down the answers we get. So that's about 4.73 there. That turns out to be about 4.30, about 4.39 for Asia, about 4.30 again for Europe, and then 2.28 for Oceania. So of course I can't take exactly 4.73, so what I'm going to do is I'm just going to round that to the nearest whole number. So that one's about 5, these ones here happen to be about 4, and that one there will take 2. So I've got a sample size, actually I've got 19 in this sample. I'm not going to worry too much about that, but this is how I might work out how many items to take from each group for my sample. So once we've worked out how many to have in each group, all we need to do then really is just do a simple random sample within each group. I've done that already on here, so hopefully you can see on the screen here. So if I scroll down and you look down that left hand column, you can see again they're not sort of like evenly spread out like they would be with systematic sampling, but what I have ensured is I have ensured that those proportions of each continent are fairly represented in my sample. Okay, quick question for you based on this idea of stratified sampling here. Have a look at that one on the screen, pause the video and then restart once you've got your answer. Okay, how did you get on with this one? So what you should have done here is you should have added together those frequencies and got the population size as 150. The sample size we want is 10. So the calculations you should have done here is you should have taken each frequency and multiplied by 10 over 150, and that would get your approximate number for your sample. So you can see that not all of these are nice whole numbers. So what we're going to do then is we're just going to round each one to the nearest whole number. So this 2.2, we'll call that 2 for our sample, and this 3.8 here, we'll call that 4. So those are the numbers you should have got from each group. Finally, I would like you to think about some advantages and disadvantages of each sampling method there. So which of these methods do you think is easier to carry out in real life? Which of these methods do you think are better at avoiding bias? Please do think about that and come up with as many things as you can here. What do you think are the strong points and the not so strong points about each of these methods? Okay, what did you write down for this then? Let me show you what I did. So for the simple random sampling, I wrote that it's usually good at avoiding bias, can occasionally give non-representative samples by chance. We saw that ourselves in our simple random sample that we did with our countries, didn't we? Also, it can be difficult to carry out in real life if the data set is quite large, because you have to generate sort of quite a lot of random numbers there. Let's move on. So can you see my systematic sampling? So this is what I wrote down about systematic sampling. We can introduce bias if there's a pattern in the sampling frame. The example I've given there is in the list of dates. Every 7th item would give the same day of the week. So if our systematic sampling method chose every 7th item in a list of dates, then it would happen to give the same day of the week, and that wouldn't necessarily represent the whole population. However, it's normally pretty easy to carry out because we only have to generate one random number and then everything else just follows. Finally, for stratified sampling, this is what I wrote for stratified sampling. Stratified sampling, it's pretty good at avoiding bias because it ensures that all groups within the population are fairly represented. But also for very large data sets, it can be even more difficult to carry out in real life than the simple random sampling because you've got a bit more processing to do and a bit more calculations to do. Okay, lots and lots of stuff in this video. If you're new to sampling methods, then there's probably a lot of thinking you need to do about this to make sure that you understand exactly what the pros and cons are of each method and how to do it as well. If you want some practice questions, exercise 1B in the textbook is where to go, but I will see you next time.